Let's see. All right, so can somebody give me a confirmation they can see my slides?
Yes.
Excellent. All right. So let me get started here. All right. So my name is David Vossel. I'm one of the core contributors to the KubeVirt project, and I'm going to talk about how we handle updates for KubeVirt. All right. So back in what I want to say was 2018, I started hearing this phrase thrown around at conferences, and the phrase was, "Let's make Kubernetes boring." And the intent behind this phrase was that operating Kubernetes it needs to be as mundane. It needs to be mundane and unexciting. So everything should just be so reliable and straightforward that performing a maintenance event, like updating the entire cluster, it really shouldn't be a big deal. It definitely shouldn't be something that we fear. So when we started looking at how to design KubeVirt's update process, that mantra of make it boring is something that really resonated with me. So updating should cause minimal to zero disruption. Our components should be capable of operating in a degraded state as new versions are rolled out. And the whole update process, it needs to be observable. So you should be able to tell easily what is going on in your cluster. So the end goal here is KubeVirt updates. I want them to be so reliable and mundane that I'd be willing to update KubeVirt in production in the middle of business hours and do that with confidence. And the only way I'd be willing to do that is if we can make some sort of guarantee around zero downtime. So to kick things off, let's talk about our commitment to zero downtime updates for KubeVirt and what exactly that means for the project. So today we have two primary commitments when it comes to zero downtime updates. The first one is that our API it's going to remain available throughout the entire update process. And what I mean by this is that the CRUD operations performed on KubeVirt objects like virtual machines, they're going to remain possible during the update. So people should be able to perform lifecycle events on virtual machines, like starting and stopping them throughout the entire update. Now, the timing of how quickly those lifecycle events are processed, it could be delayed. But the big point I'm trying to drive here is that invoking these actions should not be impacted. So our API, by design, is going to be capable of responding even in a degraded state. The second commitment is that VMI workloads will remain undisrupted throughout the entire update process. And what I mean by this is we're never going to require performing a destructive action on your virtual machine workloads as part of the update process. So if you're running a database, for example, in a KubeVirt VMI, that database is going to remain uninterrupted. Okay, I did put a small caveat here that says, unless you tell us to. And there is a situation where you might actually want to opt in to shut down event on your VMI. That would happen during an update, but we're never going to require that. And the reasoning for this, I'll get into towards the end of the presentation. I mainly put that bullet point in there just for accuracy, but I'll get to it in a little bit. Okay, that's broadly our commitment to zero downtime. And all that said, we do expect some disruption to occur during the update. And that primarily is limited to anything that involves a persistent connection between our control plane components. So the first one is the in-flight live migrations. They'll probably get terminated. It really depends on timing. And the reason for this is Vert Handler is responsible for processing the live migration streams. So that's one of our components. And when we roll out new Vert handlers, any in-flight live migration streams, they're going to get closed, which is ultimately going to cause the migration to terminate. If you're using pre-copy live migration, this isn't really a big deal. Your VMI is just going to keep running wherever it was running, and nothing's lost. Another form of disruption that we expect is any console and VNC connections to active running virtual machines. They're going to get reset. So again, this is a persistent TCP connection that's being tunneled through our Vert API component and our Vert handler components. When we roll out new versions of these components, it's going to reset those connections. And practically, there's not a lot we can do about that one. Okay, so what I want to do next. Oh, yeah, okay. So what I want to do next is I want to walk through the installation update process and talk a little bit about how it all works. So if you're installing KubeVirt for the first time, you're probably going to find some documentation on KubeVirt.io about first installing the KubeVirt operator and then posting a KubeVirt custom resource to the cluster, which in turn kind of kicks off that installation of KubeVirt. So what's going on here is we have a top-level controller, Vert operator, which is capable of orchestrating the KubeVirt install and update process. But Vert operator, it's not going to do any of that until you post the KubeVirt custom resource, which is going to give Vert operator the instructions it needs to know how to perform the update. So going through the process, you install Vert operator, you're going to post that custom resource. That's going to tell Vert operator how to install KubeVirt. We have manifests for both Vert operator and the KubeVirt custom resource, and they're published in the asset list with every one of our KubeVirt releases. So this is just a screenshot of what it would look like. I guess I'm using dark mode on my GitHub, but this is the Vert operator YAML. It's going to contain the Vert operator deployment and anything that deployment needs to work. So I'm talking about service accounts, webhooks, CRDs, whatever. And then we have the KubeVirt custom resource, so KubeVirtCR.yaml, and that's going to contain the very basic instructions that will signal Vert operator to begin the installation process. So when it comes to setting the instructions on the KubeVirt custom resource to declare what that install needs to look like, there's two approaches here. And I made up the terms here. You're not going to find this anywhere. Easy mode is what I'm going to refer to as a blank spec. So you just post a empty KubeVirt custom resource spec, and that signals the Vert operator to perform a default KubeVirt install using the exact same release of the operator that was installed. So if you install version 0.38 of the operator and you post a KubeVirt custom resource that looks like this, you will get version 0.38 of KubeVirt. Now, in advanced mode, again, totally just made up this term, is that you can pin a KubeVirt custom resource to a specific KubeVirt release. And you can do this, one way of doing this is by setting the image tag. Let me hide this. I don't know if you guys can see this or if I can just see this. Okay, so you can set the image tag on the KubeVirt custom resource, and that's going to tell Vert operator to install a previous or a specific version of KubeVirt that might not be the same one that the operator is. So why do we have two modes? Flexibility is one reason. So it allows people to use different operator and KubeVirt versions that can kind of float independently of one another. But really the big one here is rollback. So an operator, it can't transition from a release version of KubeVirt that's more recent than the currently deployed operator. So the operator has to be greater than or equal to both the current version of KubeVirt and the desired version of KubeVirt when performing the transition. So I guess here's a rollback example. If I was on version 0.38 and I want to roll back to 0.37, I'd have to have at least version 0.38 of the operator installed. And this has to do with permissions, and the new operator has to know about both everything that's required and has to have permissions to do everything required for both releases. And we only do that in a rolling forward type of fashion. So you can only roll back if you have the most recent version of that operator. Okay, let's quickly take a look at the typical installation process. And I'm going to show how you can follow that process by observing things on the KubeVirt custom resources status section. This is kind of teeing us up for observing a update in a minute. So if you're installing KubeVirt from scratch, then you're probably going to want to do something like this, where you first post the operator manifest, then post the KubeVirt custom resource, and then wait for KubeVirt custom resources status to indicate that Vert operator has completed the install. So one way you can track the progress of the install is by observing the changes to the conditions on the KubeVirt custom resource. So that wait command here at the bottom, that's telling us that the install has completed once a condition called available is set to true. So let's take a closer look at what you can expect to see in the KubeVirt custom resources status, both during and after the installation is completed. So as soon as Vert operator begins working on the KubeVirt install, that's going to be indicated in a condition called progressing. And here we can see that condition, and it gives us a nice reason for why progression condition exists, indicating that a deployment is in progress. We can also see that the phase is deploying. And after we wait a bit, and once the installation is completed, we can observe some changes. So that phase is going to go to deployed. The progressing condition is going to be set to false with a nice reason for us there. And the available condition is now set to true, which that's the thing their kube control command was waiting on. And again, it gives us a great reason that all components are ready. And lastly, if you just wanted to see all your pods in action, you could just list all your pods in that namespace that you installed KubeVirt, and you'd see, Vert API, Vert controller, handler, all these things are running and ready. Okay, so now we have KubeVirt installed. Let's take a look at what it entails to both trigger and observe the update that's in progress. If you took the easy mode for installing KubeVirt, where the operator and KubeVirt release versions are always going to remain in sync, then triggering an update is as simple as applying a new KubeVirt operator manifest, which you can find in the asset list of our official KubeVirt releases, which I had a screenshot for that earlier. So in this example, we post a new KubeVirt operator YAML. Then we wait for the progressing condition to get set in the KubeVirt CR. So that's indicating to us that the operator is now initiating the update process. And then finally, we observe the created condition is set to true, which signals to us that the update has completed. So we can have an indication of when the update has started and when it has ended. So if you're actually looking at the KubeVirt custom resources status, you can see progressing is going to be set to true. Again, we have a reason there. It's going to say update in progress. That's telling us that we're transitioning to a new version or a different version of KubeVirt. We're going to see something new here. The observed version of KubeVirt does not match the target version in our KubeVirt custom resource status. So that's telling us what the last version was that was installed and where we're headed. So it's telling us that transition's taking place, and this is what we're transitioning to. So if we wait some time, we're going to see that progressing condition is going to be set to false. Nice reason there. We're going to see that created condition, the one that we were waiting on in our kube control command, that's going to be set to true. And we're going to see that the observed version is going to match the target version now. So there's no transition taking place. Okay, so that's what it looks like from an administrative perspective to install and update KubeVirt. I want to talk about the details about what Vert operator is actually doing behind the scenes and how it orchestrates the update now. So in order to guarantee minimal disruption, Vert operator is going to be performing the KubeVirt update in a very specific and controlled order. So there's several phases involved here. The first phase is going to be involved with installing all the prerequisites required to successfully launch the new updated KubeVirt component. So this is going to involve things like installing new CRDs, meaning any new APIs in the update. And if there are new APIs that didn't exist previously, we're going to install a temporary validation webhook to block the use of these new APIs until our new components come online to actually service the APIs. So we're not going to allow people to use new APIs until we know all the infrastructure is online to actually serve those. And in order to ensure zero disruption, we're doing this thing where we merge the old RBAC permissions with the new RBAC permissions. And the reasoning for this is briefly, when we're performing the rolling update of our components, both the old and new versions are going to be running at the same time, and they both have to operate and serve requests correctly. So we have to continue with both sets of RBAC permissions in order for that to work. And lastly, we're going to install any other prerequisites that can include things like new webhooks, service endpoints, Prometheus rules, and anything else. There's a few other ones I didn't even list here. So the next phase after our prerequisite phase is we're going to roll out Vert Handler. So Vert Handler is our daemon set that lives in all the compute nodes. We roll out Vert Handler before the other components because any new VMI lifecycle features are usually coordinated by Vert Handler. So by rolling out Vert Handler before the other components, we can ensure that the logic to support any new lifecycle features, it's going to be available before the other components come online and potentially try to use those features. All right. Next, we have Vert Controller. And then after that, we have Vert API. And it's important that Vert API is the last component in this chain because Vert API is what enables new user-facing features. And by rolling out Vert API last, we can ensure that all the other components involved with these new features are available before anyone attempts to use those new features. After Vert API, we're going to after Vert API, we're going to be certain that all of the old components, all the old deployments, all the old pods involved with our control plane are down. And then we can introduce any backwards incompatible changes to our API. These would be things like introducing new versions to existing APIs and potentially deprecating old versions. Anything that might confuse our old components, we would do here. And lastly, we're going to do cleanup. So remember back in phase 1, I mentioned we have to merge in both the old and new RBAC permissions into the cluster at the same time. And this is the phase where we're going to clean up those old RBAC permissions and any other temporary objects used during the install process. So this phase is also going to clean up any old components that maybe didn't have an equivalent in the version of KubeVirt that we transition to. So if there's anything left over, we're going to catch it here as well. Okay. Wow, time is creeping up on me here. So that's a quick overview of the install and update process as it is today. If you're pretty familiar with the KubeVirt architecture, you might have noticed I never mentioned anything about updating the components that live inside the VMI pods. They're actually running the guest virtual machines. And we have a lot going on in there. So there's a KubeVirt component called Vert Launcher, and then we have libvirt and QEMU in there as well. So how are those components updated? And the short answer is, well, they're not. So as today, we don't do anything. We don't touch your VMI workloads. However, we recognize this is a problem. So if there's a vulnerability in any of these components within the VMI pod, then we need a path for automating the update of these components. And back in the very beginning of the presentation, I made a disclaimer that we're not going to touch your workloads unless you tell us to. And here's where I explain that. So I'm working on a new feature for a Vert operator that lets us declare a strategy for updating VMI workloads. And this is an opt-in feature that's configured globally on the KubeVirt custom resource. By using this new workload update strategy API, you can tell us what methods to use to update your VMI workloads. So right now, I have two methods you can use. The first one's non-destructive. It's the live migrate method, which is going to cause a VMI workload to migrate into an updated pod with all the new components. So again, non-destructive. The next one is evict, and most likely that's going to result in a VMI getting shut down. So if the VMI is managed by a VM object with the run strategy set to always, then the VMI will restart in an updated pod automatically, but that's a destructive action, or it's disruptive because it's going to actually interrupt the workload and restart it. So if you want your workloads to update in a non-disruptive manner, set this live migrate method, and that will guarantee your workloads are only impacted by live migration. And if you don't have live migration enabled in your environment for some reason, then evict is really the only option you'd have if you wanted this behavior. This feature is pretty much done. I think we'll see it in the March release of KubeVirt, but we'll see. Reviews are welcome. There's the link to the pull request. All right, so I'm going to close things out. When I said I want to make KubeVirt updates boring, one of the primary ways we can ensure it stays boring is by having a solid test suite that exercises the entire update process. So right now, on every PR, we have functional tests that execute to verify updates work between the latest official KubeVirt release to whatever code is present in that pull request. So this means that if there's anything in a pull request that breaks the update path from a previous KubeVirt release, it's not going to make it into our code base. So this test is actually gating code from being merged. These tests also verify our commitment to zero downtime for your VMI workloads. So in the test cases, we're doing things like start a VMI workload, perform an update, then validate that the VMIs are still running, and we can still lifecycle manage them after the update has completed. Okay, I tried to cover a crazy amount of ground in 20 minutes. There was a lot more I wanted to say, but yeah, I think I'm out of time. Hopefully this at least gives everyone a sense of how we approach updates in KubeVirt and some of the techniques we're using to provide our zero downtime guarantees. So maybe I have a few minutes left. I'm not really sure. Maybe if there's any questions, I can help answer those. Let's stop sharing.
So far, there have been no questions. There's a comment in the chat, but you have still a few more minutes if you want to. I mean,
sure.
Yeah, I can. Everyone to ask questions. A reminder, you can ask them here in the chat or in Slack. Sorry, go ahead.
If I have a few more minutes, then yeah, I'll keep talking. Maybe I did such a good job in my presentation, nobody had any questions because it was all perfect. So here's something I wanted to get into that I didn't get to. And during the presentation, I talked entirely about updating KubeVirt, but that's not the only update path that you have when you're running KubeVirt. You also have to deal with cluster updates. So if you're updating the cluster, then how do we avoid disruption to our virtual machine workloads when we have to do things like, for example, update a cluster node? And that is configured a little bit differently, but we have a way of doing that, and it's going to be used. We have something called the eviction strategy, and it's something that exists on our VMI API. If you set the eviction strategy to live migrate, then if you are doing a maintenance event on a node, like during an entire cluster update, we're going to gracefully migrate VMIs off of those nodes somewhere else in the cluster. Hopefully you have enough capacity. And that's what allows us to keep VMIs available. We know virtual machines are stateful, where pods are kind of ephemeral, usually. I mean, they can be stateful as well, but certainly virtual machines are usually stateful. So we want to preserve a running virtual machine, even in the case of an updated entire cluster. So using the eviction strategy, we can make virtual machines portable across nodes by setting that live migrate eviction strategy. So when a node is drained, it's automatically going to migrate our virtual machine workloads off of it. And when the node comes back up, then it will be eligible to have new virtual machine instances run on there. So that's how we're handling and supporting the case of entire cluster update. Are there any questions? I'm looking at the chat here. How does update process handle VMIs with host disks or container disks that do not support live migration? Also, does the change in API mean existing connections to that VMI will break, including console? I think there's two questions in this one. So how does the update process handle VMIs with host disks or container disks? Which update process are we talking about? I'll answer both. So the KubeVirt update process, again, we don't touch your VMI workloads unless you tell us to. So if you don't tell us to do anything, then nothing's going to happen to those. Okay, and the KubeVirt CR update. So by default, nothing's going to happen to those. They're just going to keep running. If you wanted to migrate them, then you're not going to be able to migrate with a hostess, something that's local to that specific node that it's running on. It's just not eligible for migration. So your only option, if you actually needed to update the VMI component, when I was talking about workload updates, is a VIT, which is probably going to restart your virtual machine. And the second part of that question was the change in IP, break existing connections. It's certainly going to break console because console doesn't even go through the API. I'm sorry, the IP of the VMI. It's kind of going through a back channel. As far as the API, the IP change, well, if your IP changes, then yes. But it really depends on what network you're using. So there's lots of options for setting up a virtual machine with different networks and things like that. Some of them will work successfully in a migrate, and some of them won't. So if you're using the bridge connection with the pod network, then that's one of the ones that won't work. You're going to get a new IP address. It's going to probably not be successful if you're trying to maintain persistent connections. But there's possible other network or C9 plugins, or I don't know, we need somebody from the network vertical to maybe help us out a little bit here. But there's other ways of attaching network devices that might be persistent through that. Are there any other questions? Okay. Well, follow up on the Slack channel, and especially with that networking question, you might be able to get some more detailed information from somebody who is more knowledgeable than I am about how network connections are persisted across migrations and what options you have available there.